Okay, now recording started. So let me continue my today's lecture. Okay, let me share my screen first.
Okay.
Okay, can you see my screen?
Yes, I can see.
Okay, let me open this for you. Which file is this? Not this one. This one. This is the end of my lecture. What file here? Downloads. This file. Okay, this was my file which I want to share with you. Okay. Okay, now just 1 second.
Mhm.
Hello, Joseph, can you hear me?
Yes, Walid.
Okay. This was our today's lecture. Okay, in today's lecture, we are just going to describe total solver which are present in an open form. Okay. So this lecture contains only the information about solvers. Okay.
Okay.
Okay. Just my battery is not charging. Let me just. Okay. I think it's okay. Okay. So most of the solver have self-explanatory name that least once you are with an open form. You can see there are some solver which are incompressible. What does mean by this? That these solvers are incompressible. This means that the density is constant in all these software. And for example, this is the adjoint shape optimization form, in boundary form, in channel form, in ICO form, in MRF simple form, in non-Newtonian model form. And in dimple dy form, this solver where you can see this dy is written, this means that this is dynamic solver. What does mean by the dynamic solver? We can move our whole mesh in this solver. Okay,
Okay.
are you getting my point? Yes, this whenever you see the solver with dy form, this means that in this type of solver we can just move our whole mesh. How we can just move our whole mesh? Then I will tell you how you can move. This will basically come in our advanced open form courses. We just define how you can move your mesh in an open form. Okay, in this case, for example, you can rotate your mesh, rotate your geometry, vibrate it. It's depend upon you. What do you want to do it? Your mesh or geometry. So that is the case where you see dy. dy are the dynamic solver. And the next is the pimple form. Pimple form is static solver, in which only you can just enable your basic properties of your fluid. And same is the case with the piso form, porous simple form, shell water form, simple form, SRF form, wind simple form. Okay, these are our solver where density is constant. Are you getting my point?
Yes. I use more for simple form.
Which form?
For simple form.
Porous simple form. I think you are using this one. Am I
Yes.
right?
Yes.
This one with this. Okay. You are using this
Mhm.
form, simple porous form. Okay. Thi-
Yes.
This is an incompressible. So it means that your
Mhm.
density is constant in your case. Okay.
Yes.
Yeah, okay. Now these there are some solver in which are compressible. What does mean by the compressible flow? Compressible flow means that they density is not constant in these all solver. And what are the solver? The solvers are row central form, row central DYM form. You can see here it is already written as DY. What does mean by
Mhm.
DY? I already told you. Can you just explain me what does mean by DY here?
Dynamic
Yes,
mesh.
this is the dynamic solver. You can just
Uh-huh.
move your mesh, rotate your mesh, move your whatever you want to do with your geometry. So dy means dynamic mesh. So in row central
Mhm.
dym form, you can rotate your mesh or this or translate your mesh or vibrate your mesh. It depends upon you.
Mhm.
And the next is the row simple form. This is a static solver like row porous empty form, row porous MRF simple form, row porous MRF pimple form, row simplic form, row simple form, sonic DY form. You can see here again it is written as DY. And let me highlight this in a yellow so you can see. So this means this sonic DYM form is also a dynamic solver in which we can just move or mesh. Same is the case with the
Yes.
next. The second is the sonic form, but it is not a dynamic solver. And the next one is the
Uh-huh.
sonic liquid form. Sonic liquid form means that this is the solver where you can just simple simulate your solution, but you cannot move your mesh. This is not a dynamic solver. Okay. Up till
Okay.
now, we have studied two things. What are they? Incompressible and compressible. And the next thing is multi-phase flow. What are the multi-phase flow solver? These are the solver where you can just two-phase liquid are considered. For example, one fluid name is air and the second name is water. Okay, like in the case of ship simulation in LDS interform, you can see you have two things. One is water and the next is air. When ship is running in the water, you can see there are two type of simulation are performed. One with water, the behavior of water with the ship, and the second is the with air. What are the flow properties
Mhm.
with of air with the boat? Okay.
Mhm. Okay.
So this is a solver where two or three. It depend upon the your problem, what type of problem you have, and how many fluids you want to interact with your body, or what type of your problem is. There are some for example a bubble solver, bubble form, cavitation form, compressible interform, interform. In interform you have a simulation of hull simulation. In interform you have a static simulation of your geometry, and in inter-dy form you have a dynamic
Mhm.
mesh of your hull and your geometry where you can just move your hull. What does mean by hull? A hull is a ship part through which you can perform your simulation. So in that case you can perform dynamic simulation. And in case of intermixing form, what is intermixing form? Intermixing form is also a static solver, not a dynamic solver, but it's a multi-phase solver. What about this interchange form? Interchange form is always a dynamic. No, sorry, not dynamic. It's a static solver. Same is the case with the next one. Next is MR of interform, MR of multi-phase interform, multi-phase interform, porous interform, two liquid mixing, where two liquid are mixing. This is this is the best thing where two liquid just get get mixed with each other. So in that is the case. If you have are interested to working on this, you can work on this. How two liquid are just mixed with each other in this solver. The next,
Mhm. I also with this solver I use multi-phase interform.
you are using two liquid mixing form or porous
No,
simple form.
no, multi-phase interform.
Multi, yes, you can use it. It depend upon you. What are the solver and what are your types and what do you want from your solver? Okay.
Mhm. Okay.
Okay, the same in the next is the two-phase phase Euler form. This is the Euler equation. You can just solve your Euler equation through this two-phase solver form. Okay. The next the
Okay.
combustion solver. There are different combustion solver which are present in the open form. For example, they are CHEM form, cold engine form, diesel form, engine form, fire form, PDF form, reacting form, row reacting form, and psi form. What does mean by all these things? These all things mean that they are combusting. There are different types of chemical procedures are happening in this here in chemical form and in cold engine form and a diesel engine form, fire form, PDR form, where the diesel form is the case where diesel is reacting with somebody and diesel engine, your diesel will be in engine, and that is the case with the diesel engine form. The cold form, when the cold engine is, you can see there are all types of solver which are present in the case of combustion. And the next is the particle tracking flow, where you can just capture your particles. There are different types of present here. For example, with the coal chemistry form, this is the case with the, for example, dynamic phase modeling. In Fluent, you see, if you are using Fluent, you have an idea of discrete phase modeling. So that is the cases here that are the particle tracking. Coal chemistry is also a particle tracking, and same is the ICO uncoupled kinematics partial DY form. That is a dynamic solver. And with the ISO uncoupled kinematic partial form is a solver where you can just track your particle where are they going. And the next thing is LTS reacting partial form, porous explicit source reacting partial form, reacting partial fill form, reacting partial and uncoupled kinematic. These all are the solver where you can just track your particle where they are going and where their reaction and what upon the forces on them, whether any force interact with these particles or not, did their diameter change with the passage of time or not, when two particles interact with, what about their crack, if the crack are appear on those particle or not. So this is the solver where you can just track your particles. Okay.
Okay, Walid.
Okay, next standard solver. What are the standard solver and their properties? Let us what is the first solver? The first solver is ICOFOAM. First of all, you can see what type of solver in this is an incompressible solver. Let me see it here as incompressible. Yes, ICOFOAM is already present here in incompressible. ICOFOAM is an incompressible solver. This is a transient solver. In this, you have to define your time step size. What is your time step size and your number of time, how many, after how many iterations your solution will recover, and what is your outer time step you have to define in the transient, where you have in case of study you have only defined to the number of iteration, how much number of iteration do you have, while in the case of transient solver you have also mentioned your time step. And this is the laminar flow. So what does mean by the laminar flow? Laminar flow means there are no any viscous effect are present. In this case, the fluid is considered to be a normal laminar of Newton fluid. Okay. And the second is the simple form. Simple form is a steady state solver where you have only defined that how many iteration do you need, and solve for incompressible flow where the density is the constant, and with turbulence model. Any turbulence model you want to use, you can use with simple form. If you want to use K epsilon, you can use K epsilon. If you want to use K omega, you can use any type of turbulence model you want to use with this solver, you can easily use it. And the next is the form. What is the form? Form is a transient solver for incompressible turbulent flow using the Piso logarithm. So in this is the basically a transient solver for incompressible flow. You can also use turbulence model here or any type of turbulence model. What is but the only thing is ROS. ROS means Reynolds average Navier-Stokes equation. So when you see the anything written in the solver is ROS, so this means that this is a Reynolds Navier-Stokes equation solver are present in this case. You can easily use your turbulence model with them. Okay.
Okay, well.
And there are next some basic solver. What are the basic solver? Basic solver what mean Laplacian form, potential form. What is Laplacian form? Laplacian equation solver for a scalar quantity. If you have any quantity and you want to do its Laplacian, you want to find the Laplacian equation, you can easily just imply your boundary conditions and try to do your simulate. You can easily perform Laplacian form. Same is the case the potential form. What is the potential form? Potential form flow solver which solve velocity potential to calculate the flux field. If you want to calculate the, for example, if you have a point charge placed at the center of a table and you want to calculate the flux, how many radiations or how many rays enter from one place to another, you can easily use this potential form. In that case, for you can easily calculate velocity field from that velocity potential, and the potential flow solution is a typically implied to generate in initial fields or full Navier stock code, and if you want to calculate your whole Navier stock code, then you can easily use potential forms. Okay.
Mhm.
The
Okay.
next is a scalar transport form. Scalar transport form is a solved transport equation for passive scalar. What does mean by passive scalar? Passive scalar means that if your passive mean continuous. Continuous if it is working. So right now, if anything is working in your that form, scalar transport form, so you can use scalar transport form in that case. So what about the next? Next is an incompressible flow. Incompressible flow means icoform is also a transient solver, and this is incompressible. And incompressible mean that the density is constant in this case. Non-Newtonian echo is also incompressible. This is a transient solver for incompressible. Evident and for Newtonian flows. Same is the case. The pimple form. Pimple form is also an incompressible. Sorry. Okay. Pimple form is also a transient solver with large time step. If it's time step required for its transient, and this is incompressible turbulent flow, you can use Piezo simple algorithm. Mean there are two algorithms which are mixed with the merge with one is the Piezo and second is simple. So pimple mean Piezo pimple algorithm. Okay.
Mhm. Okay.
So what does Piezoform? Piezoform is a transient solver for incompressible turbulent flow using the Piezo logarithm. You can use the Piezo logarithm in this case in the form of Piezoform. Okay.
Mhm.
And next is a
Simple
simple
form.
form. What is it? You know, simple form is an incompressible steady state solver for incompressible for turbulence model. You can only use turbulence model whether it is throttle by Q maker epsilon or any other model, single equation or two equation, you can use it with very well. Okay.
Yeah. Okay, got it.
Mm, sorry. Yes. Okay. So this is the okay. So I will send you this file. You can also read this file. Okay. There are. Let me just
Mhm.
go through and I will through and tell you if you have any question. Then you can ask me. There are some solvers which are compressible. You can see here row central form, row pimple form, row simple form, sonic form. These all are compressible in the form of this. These all are the solver with the heat transfer. Okay, and these all are the solver with a multi-phase where you can interact with your server. This is the detailed data. In this case, you can easily understand what are these means. And these are solver the multi-phase, the cavitation form, compressible interform, change form. You can also use the volume of a fluid. What does mean by VOF? VOF mean like ship and water, and your ship is working running on the water and surface, but air is also interacting with your also, that is the case with the volumes of fluid. And what are electromagnetic? There are also electromagnetic solver which are present in the open form. For example, the electrostatic form, magnetic form, HDMI form. You can also perform your these type of simulation in the open form. Okay, and our view of a turbulence model. There are different turbulence models present here in the open form. The turbulence dictionary is used to read by any solver that include turbulence modeling within the find simulation time. Keyword control the types of turbulence modeling. For example, laminar. Uses no turbulent laminar. Not any model. So this means there is a no viscous effect. So you cannot use any turbulence model in this case. Ross, what does mean? Ross means does used by Reynolds every Navius one. LES. LES is a large eddy simulation. Some part its model and while other is directly calculated from the equation. Same is the case with the incompressible ROS. There you can see these all are the turbulence model which are present. I'm not just going in a trail. I'm just giving you an overview of these turbulence model. LRR, lame brake, lender sheet, line cubic, line Schussner, CNK epsilon, SSG, and then Shell quadratic kinetics, Portal Marans, K epsilon, K omega SST, K omega SST LM, K omega SST SAS, K L omega, Q zeta, label KE, VDF2. These all are the solver present in the open form. Then there will be a compressible roster because all of them are same. There is no need to change it. They are same. Turbulence models are same. Nothing to need to be changed. Incompressible LES turbulence model. Sorry. Incompressible LES turbulence model. These where the density is your constant. You can see and radar or diff stress, sismography, spottle models, DS, spottle model, DS, IDDS, Wales dynamic K equivalent, dynamic Lagrangian K equivalent, and K omega studies. And compressible LES turbulence models are also present in the open form. You can check them if you want and if you use them. Model coefficient. What does mean by the model coefficient? Okay, the model coefficient means the coefficient for the roster plus models are given the value in their respective sources code. For example, if you have written any code in which you have just defined your code and these you can define these coefficient in your models. Once you have defined and then they are changed, then you can easily access that code. You can open because OpenFOAM is an open source. So open source provides you this utility. You can easily read your directory where your basic installation is done or your basic code is present. So if the user wishes to override these default values, they can do it by adding a sub-dictionary entry to ROS by a sub-dictionary file whose keyword name is that the model within a coefficient of peng k epsilon coefficient or the epsilon model. So what does mean by this? This means if you want to write anything about that model, you can easily change that model and you can put your own values, but the name of the file must be changed. So for example, if the old file is present with the name .x uh, RAMIRIG, and if you want to change that file with a new file, you have to just change the name of the file and place it in a correct dictionary or directory. Okay, coefficient dictionary is printed to a standard output when the model is created at the beginning of a run. Whenever if you want to run your case file or directory, then they are always present at your directory or your destination location. The user can simply copy into the raw sub-dictionary file and read it, and the entries are required. The entries automatically will be required in this case. So you can use raw sub-dictionary. Okay. If you have any question right now regarding all this, you can ask me.
Maybe we use other. Is that all solvers that we can see in OpenFOAM, or there are more that not included in that?
There is another version of OpenFOAM is present, which means that is an extend version of OpenFOAM. We can call it the extend OpenFOAM. In that cases, you can see around more than 200 cases are present in OpenFOAM extend. Okay.
Okay, it's a lot.
Good.
Maybe I use more related to BOF
Yes.
volume of fuel.
Yes. Volume
That
of fluid you can use. Okay.
yes,
So,
yes.
okay, these are the basic thing from if you want to convert your mesh from OpenFOAM to any other software or any other software you want to just change the mesh. For example, this is the meshing strategy. OpenFOAM is a Cartesian coordinate, so you must have an idea about of how you can just place your point in 3 dimensions. OpenFOAM always create a mesh in a 3D, not in a 2D. Okay.
Okay.
Even if there is a case in 1 dimension, if you are writing a case in a 1 direction, then it is necessary to at least one cell in each direction. So there is a one cell in each direction, and if you are continuously working on that thing, okay. So in neutral, there are 3 ways how to create mesh for OpenFOAM. What are these things? First is the creating mesh in a block mesh part of an OpenFOAM. If you have a great idea of an OpenFOAM, how OpenFOAM is using and how you are using your block mesh. Okay, block mesh is the case where you can easily just do your own mesh. This is the first step. What is the second step? The second step is the generating mesh in a snappy hex mesh part of OpenFOAM. Yes, you can also create your mesh in the OpenFOAM. It is very difficult to create your mesh by using snappy hex mesh. You need very high language in order to understand what means by this term, what means by this term. You have to define all those terms, and then you can easily learn what is a snappy hex mesh. Okay.
Okay.
The next step is the creating mesh with the tools importing into OpenFOAM. And if you have not succeeded with the block mesh and OpenFOAM, and you want to just import your mesh from any other software to this software, you can easily import your software in this case and you can run your simulations. Okay. And following are the command to convert from the one thing to other thing, that is the answers to form, CFX to form, data to form, fluent 3D mesh to form, fluent mesh to form mesh to fluent, form task to max, form to surface, form to boundary, and mesh to form. So these all are the solver where you can just convert your simulation into OpenFOAM, and if you want to convert your simulation from OpenFOAM to any other software, then you can easily click and just convert to that files. Okay.
Okay.
Up till now, if you can, you have any question, you can ask me, then I will proceed further.
Maybe when we use or when we create a mesh with snappy hash mesh, we use CAD files like LST.
LESC is a
Or
large area simulation.
okay.
Sorry, I'm not understanding what are you saying. Can you ask one again?
It's the format of the file that snappy hash mesh needs to for introduce into the model when
Yes, we can.
creating.
I will send you this file with. I can share with this file with you. Okay.
Okay.
Hmm. Okay, let me just go from here again. Generation the block mesh. So in this case, we are just explaining only what is block mesh. Okay. Yes, this section describes the mesh generating with block utility and smiled with supplied with OpenFOAM. The block mesh utility called at a promo electrium Hemans. Let me just see this thing on screen here. Yes, parametric mesh with a grading and curve edges. Okay. The mesh is generated from a dictionary. Yes, we already know about this, how a block mesh exactly work. We have a directory which name is a block mesh. We can change our parameters, our vertices, our blocks, our boundary conditions, our merge edges patch, or anything else. We just change in our block mesh. So block mesh is the most important part in our simulation. Okay. In the system or a constant of polymesh, you can see your mesh is always present in the system directory, which is has another folder, and you see that in polymesh your all files are present automatically. And directory block mesh reads and dictionary, generate the mesh and write out the mesh data to point cell interfaces and boundary and file in the same directory. If you have both of them, then they are both of them, no issue. But this due to this, you can easily just click and you generate your desired geometry. So the local coordinate system which you find in the order of the reverse or run the block coordinate, the the axis origin is the first entry to define blocks, vertex 0 in our example. The second one is x1 direction is denoted from 0 to vertex 1. The third is the direction is described by moving from vertex 1 to 2. So the radius 0.1 to 3 define as a line x3 is equal to 0. So what that means? So this means x3 is missing today. Okay. And what is mean by 4? Vertex 4 is formed by moving the vertex 0 in the x direction. Whenever you move, you can automatically just create your block. So vertex 5, 6, 7 are similarly formed by moving x3 in the direction from vertices 1, 2, and 3 respectively. You will easily move them or handle them. Okay.
Okay, Wally.
Next one. Yes, this is the case. You can see we have already an idea how just and simple blocking work. You can see in this case it described very well that the direction of the block is always in a clockwise, so you can easily handle what type of mesh is it. Convertometer means 0.012 millimeter and meters means 000 and edge means 0.4439 if you want to create a certain type of edge. And if you want to patches, you can easily use simple plan. Simple plan is the best patcher in your case. Convertometer means arcs, spline, polylines by and you can easily use them as well. Simple grading. What does mean by simple grading in x1, x2, and x3? X1, x2 means that there is are some things. For example, if you want a distance between each block is 1 1, you can easily put the value of 1 1, and if you want less distance, then you can easily make forward something, and you can easily do this type of things. In this case, in a simple case, most probably most people use 1 1 1 1 is a bus, and if you want to calculate for your wall function, then you can easily calculate in this case.
Mhm.
Edge grading. Edge grading mean expansion ratio over expansion ratio. Expansion ratio and directions are both always must be same. The first, the fuel cell explained by describing the description gives a ratio for each of a block with the arrow head in filling in the direction of fall. The last cell is in a grading. This means that the ratio of a cell with 0.1 and the along edge 47032. In the case of dimensions, you can easily just define them how you can easily define them. So this is the expansion ratio divided by direction ratio. You can easily calculate what is the delta x. Delta x is the most important case in the meshing. So here is an example of a simple mesh, how we are just defining our mesh. So this is the case. For example, this is a simple mesh using a simple expansion ratio to describe mesh grading permit only one way grading with a mesh block. In some cases, it reduce complexity effort to able to control guiding with the separate regions of a single rather than to have define a several blocks with a one gradient per block. For example, to mesh channel two opposite walls and grade and the mesh toward the wall require three region, two grading and two with a wall with the one with the middle grading. So grading means 10 30, 10 300 and 100, and the blocks block is 0 1 2 3 4 5 6 7. Yes, this is a Q box, and its grading is 100, means 100 number of cells along x axis, and 300 means 300 number of steps along y axis. And what does mean by 100? 100 means 100 number of blocks or cells along Z campus. So you can easily define, you can see at the end there is a cell expansion ratio. This means 0.3, 0 by 4 is equal to 4. You can easily divide then 20% of y with 30. Automatically cell expansion ratio is 4. So it depends upon what type of cell expansion you want. You can easily define in your direction. Okay.
Mhm.
So I think
Okay.
up till now, this is the overview of models. If you have any question regarding this, you can ask me right now. Then we can move on further lecture.
No, it's okay. I understand that. That's the way.
If you have
Um,
any difficulty in my lecture, whether I'm giving this a lecture you are not understanding, or I am going little far, then you can stop me and ask question. Okay, that's your right. Okay.
okay, got it.
Okay. Now let me just close this and open another one. Hmm, just give me 1 minute.
Okay.
Let me close this thing. This is not flowing here and not opening. Okay, now you can share your screen.
Yes, I can see you. Perfect.
Okay, let me stop my screen so I can see your screen. Okay, now you can share screen. Joseph, share your screen.
Okay. Mm, Okay.
Okay, open your Ubuntu terminal and show me your simulation. Did you perform your simulations of your block or not? LS here and enter. Okay, open bits daily. LS here. Remove all these files starting from 100 up to NES. Just leave 0, constant, and system. Okay, remove everything else.
I think it's remove RF.
Name of file,
That's
which file? Good, enter.
that's okay.
LS here. Now you can see, you cannot see. First of all, remove RM, remove LS enter. Now you can see the 1000 is removed. Okay, now you have to remove all these. Okay, go ahead and remove it. I'm not speaking right now. I'm just seeing what are you doing with it.
I am remove 1300 RF 1500 RF 100 1700 one 2000. I remove 2000 for the 100 1600.
Now LS and check how many files. Okay, remove 100, 200, 300, 400, 800, 9 and 900. Remove them.
Uh,
LS here again. Now remove post processing.
okay. RF.
Now open your system directory and write 10,000, not 1 lakh iteration. Let us see how many time it will done. See the system, open system directory, cd space system. LS here and enter.
Okay.
Okay. Now open your control directory, write VIM space control dict. Enter. Just go at up, little up, more. Okay, just settle down. Or or okay, right here. Remove 2 from end time and write 10 here. There. Remove 2 from end. Sorry, at start end time. At end time, remove 2 and write here 10. Remove this 10, write here 10.
I gonna put in or I changed 2000.
Yes, sir.
I put 10.
No. Remove, just put 1 0 once at the start. Write 1 0 0 1 0 0 0. Now remove this one. Remove this one. Write 0. Again 0. Again 0. Press
1
escape.
million.
Yeah, that is the end time value. Okay. Now press escape,
Okay.
shift colon W key. Press escape from your keyboard. W key, enter. Now just go one directly back and run your simulation. Right here, not block mesh, right here, simple form and enter.
Oh.
Okay, now let's wait and see after how many time it will take your simulation around 1 lakh. Okay, your system is much more powerful. I'm seeing right now. Okay. If you have any question right now, you can ask me.
Maybe when it is simulating, appears, for example, CFL, a smooth solver, I think, or other is GAMG.
Yes, these are the values of velocity, the component of velocity where when the particle move in x direction, y direction, or z direction, it is calculating your all velocity along x component, along y component, along z component. Okay.
And also, when we change the current number, it will change,
Yes,
reduce
current number directly affect your mesh because your current number depend is directly related with your time step. You can easily you have the formula of current number with your time step. Your current number is directly related with time step. Which when you just change your current number, it directly affects your simulation and your result will automatically change by affecting your current number. Okay.
Mhm. Other question, well, it will be uh, when for example, when we finish that simulation, for delete all the folder is through the Ubuntu terminal or only can delete with a folder
You can also
using.
delete by just writing in your Terminal Explorer .exe, then open, and you can delete file from them, and you can also delete in your terminal. Okay.
This is the question because when I was working on VirtualBox, when I deleted the space of the disks continue with the
Then you can. Then the thing is, you can easily delete them. But when if you want to write your cases, you can write for small time, not for many time. For example, in this case, we are writing about 10,000 time, and your continuously your pattern are written. Then in that case, you can write for 20,000, for 10,000 for one time step, then 10,000 for next time. Then you will write cases after 10,000, 20,000, 40,000. Then it depends upon you how much you time step you required, okay?
Mhm.
Or how many
But yeah,
you required.
but these have or these need space,
Yes, yes.
capacity of the
In this
memory.
case, but this is the only thing you can use, okay? But it depend upon your problem or what how many steps you required a good resolution, or if you want to create any animations, then you can create much cases, okay?
Mhm. Okay, that's a problem that that happened in the virtual box and also.
In most of the cases, student, this problem occur because OpenFOAM automatically writes so much uh, step, and it will create problem. Most of people use SSD. SSD is a soft drive. This drive, they have only 238 or 256 GB of SSD. In that case, it cause problem. While in case of if you have a hard disk of around 2 terabytes, it will not affect your system. Okay.
Okay. But also with the number of videos that I made, this complete near to 500 gigabytes, I guess.
No issue. Then you can
Yes.
write in a one or two cases. No need to write anymore. Okay.
Okay. Okay.
The main purpose of your simulation is to get the result in output, not to get your best animation. And if you want to get best animation results, you want to create any video, then you can write much time step as you want. But in that case, you require a lot of space. Okay.
Hmm. Also, if what happened, for example, is now the laptop, the power of the laptop finishes, and also what happened with the simulation? It started
You
from
can just simply check at your. Let me give you remote. I will tell you how your PC is working now. Okay. Where is remote control? Okay. Access it.
okay.
Now let me tell you how your PC is consuming. Or right here, let me just minimize this terminal, and right here, taskbar. I cannot see task TA. What happened?
Tax
TASK.
tax manager.
Yes, task manager, right here, task manager. This is the task manager.
Yes, it's the thing. Yes, yes, it's tax manager.
Let me open this here and go to this thing, performance. I cannot click over there. Can you click on them? I cannot click on them.
Here, I click or right click.
I cannot see your desktop right now. Okay, now I can see. Okay. Just 1 second, let me click over there. Okay, click at this second one up. You can see at the process second with RED up at the top processes where you see processes at the top, at the top, at the top, at the top, at the top. Move your
Oh yeah.
mouse. Yes, click over this. Okay, you can see this is your how your process is working right now, because simulation is working right now in your PC. So that you can see 46% of your PC is you have an graphic card of Intel which is 4. It is using in a good direction, so you can monitor your processor from here. Okay,
Mhm. Okay.
that's the
Also,
for
that
monitoring.
in the memory is 6.8 to 11.8.
Yes, so we have memory of this. Okay.
Okay.
Number of logical cores you have 4 and number of physical cores you have 4. This is the best thing in the world. Okay, open your geometry terminal and see how much.
I think it continue working.
Okay,
What if I need to
minimize this
stop?
terminal and open another terminal.
Okay.
Right here, top, enter. You can also monitor your processor, how it is working. You can see here it is written as 100. Okay.
Mm-hmm.
Now just press Control C from your keyboard and Control C from your keyboard. Control C.
Control C.
Okay. Now press right here, clear and enter. Enter ls here. Now open Pits Daily. Go to Pits Daily CT space Pits Daily. Enter ls here. Now you can see there are a lot of writing in your processor. Okay.
Mm-hmm.
So due to these large amount of cases, it requires much more space. Okay.
Yes.
And
yes.
that is why right now you have how much space in your C drive?
This is
C drive. Like you have SSD. So that's the point. So let's see after it has, yes, 172 GB. Let's see how much it requires. Okay, because your terminal is in right on your C, so in your C directory. Okay. Okay, just minimize it. Okay, just remove some, for example, remove 100 to 1000. Okay, remove them from 100 to 1000.
From which folder?
100 to 1000, from 100 to 1000. RM minus RF, you have to write also RF. 100, enter. Now 200 up to 1000.
Is necessary to do manually each by each wave on one?
Okay, do it manually.
Okay, it's not possible to put from 100 to the other.
Okay, do it manually. There is a procedure, you can do it manually. There is one another way, but okay, go ahead from this. Do not remove 1000, okay?
Okay. 1000.
I said do not remove 1000 and you just remove 1000 first of all.
Okay. I think I finished.
Okay, ls here, enter. Okay, now I think your simulation are done. Can you open your terminal?
Please continue. We put 1 million the time that we finish.
Sorry?
I think it's continue because we put 1 million the time.
It will just stop after 5 or 10 minutes. Minimize it and open it. Some of your in your Explorer actually, which are written here. Okay. Minimize and write at daily. Explorer.exe and copy and paste at your desktop. Let us see how this is going on. Okay, close this task manager.
I write Explorer.
Yes, explorer.exe, copy and paste at your desktop. You can see due to heavy size, it is taking too much time.
It's a heavy folder.
Okay. Open this thing in a para view. Open your para view and they are copying.
Okay.
Okay, open.
What I do now? What I need to? Okay.
Nothing is
Did not
happening.
change. Nothing. Not change. Not.
Just wait for 1 second.
I can't see any change.
Now can you see change?
Mm-hmm.
That means it's the perfect.
But why don't change the field U, capital U?
1 second. There is a problem with your boundary condition. I think that's why U is not working exact. Okay.
Okay.
In case of U, you have some error. You have to correct it like this. When I have just seen this thing, no? Right here, it is. I can go for this. Apply. Now let me apply to. Now you can see. Yes, this is a good thing right now. That just 1 second, give me Joseph, okay?
Okay, Walid.
Just wait, don't move anything here from here. I'm just coming in a 1 minute, okay?
Okay.
Okay, Joseph. I'm back. So let me just click over here once again. So you can see it. Okay, good. Let me check anything more from here. It's Omega. Let me see about this thing. And this thing, hot and cold, apply it, close it. Now let me do it. Now you can see why is this happening? Because our boundary conditions are too low due to the effect of this boundary. Okay, this is
Okay.
not exact solution. This is because we have problem with our boundary condition. We have to just increase its space along y-axis in this direction from this point to this point, and from this point to from this point. We have to move it in this direction. When we will space and remove these boundary and at a large distance, then there will be no any effect and it will do our best simulation. So that is the case with the velocity. You can see when we just click yes and apply okay, we cannot see anything here. Why? This is
Yes.
because, let me just move in this direction whether I see anything here. No, nothing. Why? This is because this is the block where the velocity do not affect. This is only, let me just re-able from here. So might be I can see. Just let me stop here. Okay, it is automatically stopped here. Let me rearrange from here. Yes, now I can see. Okay. So this was the reason I cannot see. I just reset it. You know, exactly. Okay, this is Z negative. Okay, let me zone this thing, and now let me click over here. Okay, now you can see your velocity is also
No.
okay.
Mhm.
So the reason is this, that this boundary is affecting our block in a not in a good way. Okay. That now let me just central enable it at start point, not at endpoint. Endpoint is like this. Now let me enable my pressure. Let me check what about this. Yes, this is in a good way. My pressure is right now. So it is this and apply. Now check my pressure. Okay, good. Now can you see? This is the
Mhm.
pressure variation, and one of them is leaving detection right now. Blocks. So let me just stop it and change my jet so I can see them. What is happening with it? Okay, now let me just okay, now you can see there's a vertex forming at the end. Okay,
Mhm.
so why this is
Okay.
due to our boundary condition. We have to stop it and do it in a good direction. So your homework is you have to extend the boundary condition in y direction and in along x direction. Okay,
Okay.
let me just stop from here and give you detail how you have to make your view of more. Now stop your sharing screen and stop your simulation. First of all, minimize it and stop your simulation. Open Ubuntu terminal. Open Ubuntu terminal. Right, just simply click Control plus C. Control plus C from your keyboard. Press Control plus C from your keyboard. Okay. Now minimize it. Okay. Now stop your sharing screen. Okay. Now let me share me the whiteboard. This is the whiteboard. Let me share with this. This is our domain, for example. Okay.
Right.
This is the block which we have placed here. Like this. Okay. And then like this. This. And then this one. And then like this one. Okay. Now you have to increase your direction along this thing. Okay. This is your y positive. Okay. And this is your y negative. And this is your x positive. Now you have to increase this direction, increase this direction, increase this. From which point? From this point. From this point to upward, you have to increase value of all these points. Okay. This what is your this boundary condition? This boundary condition is your upper wall or walls. Okay. So your both them are wall. So you have to increase its value and you have to increase also of your value of this. Okay, let me just.
Okay.
This is your walls. These both are walls. Okay. And this one was your outlet. You have to increase direction. For example, um, this up one is 30. Okay, from this point. Okay, and from this point to this point minus 30 at the bottom, and from this might be 50 or 60. Okay, change its direction. When you can change these things, it will automatically affect your simulation and your results will become 100% accurate. Okay.
That I think about what it is that I changed for example, in our case, is I don't know, is five, no? This is five. And from this, I maybe this is five, and also I changed from 5 to near to 10. Is possible?
Yes, you can change it to 10. Go to no issue. You can change 10. You can change it to 2 times. For example, change it to 15. Do it this thing to 15. Okay. This is 15 and this will be also 15. Then do this thing along. This is 30. What about from this point to this point? Do it to 30. Okay.
Okay.
So this was
Okay.
the point. Due to these things, our results are not coming in exact way. There will be a little error. So remove these error, we have to increase our boundary conditions. Okay.
Okay.
Are you getting my point?
Okay. Yes, I need to change the structure of the block.
Okay. So that was my today's lecture because I missed your tomorrow class. I was ill, so that's why I didn't take your class. So I am taking this. So if you have any more questions, you can ask me, unless we can leave.
No, for that reason, for today it's okay. I think is maybe we go the snappy hash mesh is start with Monday. No? That is
Okay, so we can start our snappy hex mesh from tomorrow. Okay, tomorrow is Saturday, and we will have our class at 7 a.m. Okay.
okay. Okay.
According to my time, it's 7 p.m. and according to your time, and it's I think 10 p.m. 10 a.m.
Yes, yes. Tomorrow and at that time. That's
Okay.
okay. Okay, Wally.
Okay then. Bye bye. Take care.
See you tomorrow, Wally.
See you.